Hello, I welcome you all in this presentation related with the subject material processing fundamentals and practical. This is the second lecture, and in this lecture primarily I will be talking about the modern trends in materials processing, a comparison of the material processing with the manufacturing and production engineering, and also we will try to look into the greater detail of the common material processing methods like casting, welding, forming, machining and their capabilities. So, in this lecture I will be covering these following topics as I have just said. And then as far as the modern trends in material processing is concerned, additive manufacturing is one of the most recent and very popular research area, that is the additive manufacturing. And in additive manufacturing the variety of the processes and approaches are used, like where we use the sheets for achieving the products, or we use the powders, or we use the wires and the rods, and then these are like the sheets are then processed, cut and then joined using the suitable processes to get the desired size and shape. In case of the powder, things are fused, or things can be fused using the heat from the suitable source, and likewise in case of the wires and powders. And we can also use the liquids, and this method is particularly used for the polymers. So, their polymerization is done using the suitable kind of the radiations. So, the advantage of the additive manufacturing is that we can manufacture the products very quickly using the layer by layer approach, and that in turn helps in bringing the product in the market very quickly and launching the product. Apart from this, additive manufacturing also allows the fabrication of the prototypes, so that the newly designed products can be tested and their viability, suitability can be examined for production later on. The micro and nano materials and the relevant fabrications is the another area which is particularly used for developing the newer materials, and these materials offer very high performance during the service, which in turn helps in increasing the reliability and the capabilities of the systems which are made of the micro and nano materials. At the same time, micro and nano fabrication is also being heavily used, especially in the medical, in electronics, to either produce the products of the very fine size, or the products having the features of the micro or nano size. The sustainable manufacturing is the another very hot area where the people are working to ensure that the processes can be made more eco-friendly, so that the impact of producing goods on the environment is minimized, and this has led to the development of the approaches like green manufacturing, and then the use of the recovery and reuse of the material. Okay, recovery and reuse of the material to avoid the wastage. Idea here is how to minimize the wastage, and also development of the eco-friendly and energy efficient processes, so that the burden of the producing goods on the environment can be minimized. So, we will see little in more detail about the additive manufacturing. This is a relatively new technology commonly known as the rapid prototyping, abbreviated as RP. 3D printing, because through the sequence layer by layer approach of producing the 2D layers, the 3D products are made, and the common processes are like the FDM, okay, the SLA, SLS, binder jetting, wet polymerization. These are the very common processes used for both metals as well as the polymers. Okay. This is primarily used for making the prototypes, so that the initial stage of the design, when the prototype is made available, we can check the appearance, the functionality, the performance properties, and the suitability for the end application. And wide variety of the products, additive manufacturing is also used for producing the products in a relatively smaller quantity, but in large variety. So, when we need to make the products to satisfy the market demand in a smaller quantity, but variety of the product designs, then this approach of the material processing is found to be good. This process is particularly being used for low melting point materials like polymers. Currently, this is popular for the polymers, but a lot of efforts are also being made to develop the suitable technologies for metal processing by additive manufacturing, so that the real engineering components can be made using the metals through the additive manufacturing route. This process is still under the development, and a lot of efforts are being made currently for developing and maturing the additive manufacturing technologies for processing the metals. The quickness of the process allows the fast production and the customization. So, this in turn results in reduces the time to launch the product to the market, because we can make the prototype and we can check its suitability and functionality. So, that will reduce the risks related with the rework change in the product design later on, if the product prototype has been made and it has been successfully checked and evaluated. It also helps in reducing the cost effectiveness, and it improves the customization of the product. You see, so when we need variety of the products in terms of the designs, then this approach allows the customization and design change very easily, and this can be done cost effectively using the additive manufacturing approach. So, as I said earlier, the materials in variety of forms like sheet, so sheet laminated at additive manufacturing approach, the powders of the metals or the polymers are used in the fusion based approaches of the additive manufacturing, and then the liquid is used in case of say wet polymerization. This is used for the polymers. Okay. Each process is different in terms of the capability, in terms of the speed of manufacturing, and since we are able to get the general shape and size of the product, most of the time the products made using the additive manufacturing approaches need the secondary processing to achieve the final surface finish and the dimensional tolerance or the control over the dimensions. So, the products made using the additive manufacturing are close to the desired one in terms of the size and shape, but to get the final products which can directly be used for the engineering applications and effective performance, the additively manufactured products require the secondary processing to achieve the desired dimensional control and surface finish. Micro and nano material processing, under this, like development of technologies for the nano material is currently underway to make the processes scalable. You see, people are able to produce the nano materials in a smaller quantity, but if you have to make these in larger quantity for industrial applications, that to cost effectively, then the processes technologies are being developed so that the nano material production technologies are made scalable, they are made efficient, effective and economical. The manufacturing of the nano materials is not just difficult, it is difficult to scale up. The processes are not that efficient and they are not economical. So, a lot of efforts are being made on this front, and then technologies are being developed to realizing the micro size products for electronics, energy storage and medical applications. So, not just the nano or micro or nano material development is being undertaken, but also manufacturing the goods products either of the micro or nano size, or the products and goods having the micro or nano size features. These technologies are being developed so that the relevant products can be made effectively, economically and efficiently for applications in electronics, energy storage and medical applications. Then the sustainable manufacturing is the another aspect as far as the current trends in materials processing is concerned. Sustainable material processing, what it involves, like green manufacturing, and in the green manufacturing it involves the development and applications of environment friendly practices aimed at reducing wastes, lowering the greenhouse emissions and using the renewable resources during the production and the life cycle. So, idea behind the development of technologies under the green manufacturing is that either wastages are reduced or the wastages being produced during manufacturing in terms of the greenhouse gas emissions, that is minimized, and as far as possible then the energy is used more efficiently or the renewable sources are used for the manufacturing purpose. The recycling of the process is another other two aspects related with the sustainable material processing is recycling processes, modern recycling techniques for various materials with the focus on material recovery and reuse. So, lot of work is being done like how to recover the useful materials from the product which is being discarded, and therefore like say in a car there can be multiple kind of the metals and materials which are used, and once the car is discarded efforts are made to recover whatever the useful materials can be recovered from the same. Okay. And if not everything can be recovered, then also possibility is explored what parts and what material can be reused again for making the products. So, the recycling involves like as far as possible recover the material from the product which is being discarded, or if possible reuse the parts and certain the materials which are being obtained from the discarded product. Okay, after the completion of life cycle. Say energy efficient techniques development, what it involves is the development of methods to enhance the energy efficient material processing, and so that the systems work with very less level of the energy, and this is done using the suitable sensor technologies, using the proper energy management systems and waste heat recovery. So, these are the few aspects through which efforts are made to make the processes more energy efficient and to ensure the recycling through the recovery of the material and the reuse of the material, and developing the technologies for the green manufacturing. Okay, as far as the conventional material processing is concerned, as we know that the primary shaping processes using the casting and forming, this category is one of the most commonly used material processing route for making the goods. Secondary processing like finishing and the welding, and then the finishing processes like the grinding and super finishing, and property enhancement the processes like heat treatment and surface modification. If we try to see during the processing like say the casting, forming and the welding, the kind of thermal cycle which is imposed significantly affects the material structure and properties. So, if we try to see how the different metals when they are subjected to the material processing by casting, by forming and by welding, what kind of the thermal cycle is imposed. So, if we see the thermal cycle imposed during the welding is, thermal cycle indicates the variation in temperature of the material as a function of time. This is the thermal cycle. Okay. So, thermal cycle imposed during the welding is very high rate of heating, where increase in temperature is very fast with respect to the time. Okay. And then fast cooling. So, the rate of heating is high, rate of cooling is high, and the peak temperature, this corresponds to the fusion temperature of the metal. Similarly, for casting the rate of heating is relatively low, then the high temperature is maintained for longer time, okay, and then rate of cooling is also low. So, the both welding and casting involves fusion. So, the metal is heated little higher temperature above its melting temperature, say this is the melting temperature, okay. And then third is the forming. No external heat is used in cold forming, but in hot forming certainly heating is done. So, metal is heated to the high temperature, this is usually above the recrystallization temperature, and then it is cooled slowly. Okay. So, if we see the difference in these the three processes, so the maximum temperature attained during the casting and welding is corresponding to the melting temperature or a little higher than the melting temperature of the metal being processed, but for forming it is above the recrystallization temperature. Rate of heating and cooling is very high in case of welding, but rate of heating and cooling is slow in case of casting, and in case of the forming it is further slower. Okay. So, since the weld thermal cycle significantly affects the material structure and properties. Therefore, it becomes important to consider the thermal cycle when we are talking about the manufacturing material processing approach. Okay. So, usually when the melting happens, then we get the liquid metal followed by the solidification to produce the product, but this in turn results in the cast structure. Cast structure considered to be weaker than the deformed structures where the material is subjected to the kind of plastic deformation. Okay. And whenever there is a liquid to solid state transformation, there will always be tendency for having the defects like porosity, inclusions. So, these are the like say the side effect of processing the metals through the welding and the casting route. So, the presence of defects and the cast structure during the welding and casting, welding by fusion and the casting, this in turn results in the relatively poor mechanical properties, lower mechanical properties as compared to that of the forming. So, forming can be cold or forming can be hot. In case of the hot forming, only the metal is heated above the recrystallization temperature. Then other processing route, say machining, usually there is no heating. So, we do not talk about the thermal cycle during the machining except in hot machining, but mostly machining is done under the ambient condition. This approach works simply based on the removal of the unwanted extra material to get the desired size and shape. When the product is made by casting, forming or by welding, we do not get very good surface finish. Similarly, the control over the dimensions is very limited. So, the dimension or you can say the tolerance realized is not very close. Dimensions are always away from the desired one, and therefore, it is always required to use the secondary processing in form of machining or thereafter grinding and super finishing. Grinding helps in realizing the very high degree of the surface finish, means very low surface roughness value, and it also helps in realizing the very high level of the surface finish. So, very low RA means high surface finish. Okay. When the product is made, say material subjected to the processing through the casting, forming, machining and welding, okay, or even after the grinding, there is always a tendency of the alteration in properties of the metal. Like say metal A is subjected to the material processing. Initially it will have some set of the properties, but when it is subjected to the processing either through the use of the heat or through the plastic deformation or both, this is going to change the structure of the material and that in turn affects the properties. Material being made, material being processed to achieve the desired size and shape and make a product. At the end it should have the desired set of the properties. If the material does not have desired set of the properties, then it will not perform satisfactorily during the service and it will fail prematurely. Okay. Therefore, it is important that if there is any alteration, modification in properties of the material during the material processing, then the properties must be restored. So, or the properties are enhanced. Therefore, property enhancement is done through the structural modification through the heat treatment, this is one, or surface modification using the suitable surface modification techniques. Okay. So, in case of the heat treatment, entire bulk material properties will get modified, but in case of the surface modification, only the surface layer properties will get modified. Core will remain same, only the surface characteristics will be modified. So, this is one. So, one of the approaches where over the surface of the substrate, the material is subjected to the application of a better quality material. Say this is the substrate, low quality material, and we want better quality, better surface properties at the surface. So, we will be applying a layer of a better quality material over the surface of the substrate. So, this application of a thin layer of the material of the desired properties for a given functionality, this approach is known as coating. So, the galvanization is like the application of the zinc coating over the steel for enhancing the corrosion resistance is one of the common approach. Likewise, anodizing or the chromium coatings or the other approaches where some kind of the layer of the desired material is applied over the surface of a substrate to enhance the or to achieve the desired set of the properties. So, if we try to compare the material processes used for material processing and their capabilities, then the casting, it helps to make the material processing capabilities, say, examine in terms of the ability to produce the geometry, whether it is simple or complex, size from few milligrams to few tons, tolerance, the dimensional control possible, and surface roughness that is realized. So, as far as the casting is concerned, it can be used for making the products from simple to complex shape, is very small to the large size, tolerance is moderate, and the roughness is high. Like it can vary, say, from 5 micrometer to the 50 micrometer. Okay. Then the size from few milligrams, products of few mg in weight to tons. Okay, from very simple shapes to the complex shapes. Welding is relatively used for making the relatively simple shapes, very small to the large size components, like the ships are also made using the welding by joining the simple steel plates. Then tolerance is very low, we are not able to achieve the good tolerance, and the roughness is high. The forming used for making relatively simple shapes is small to the medium size components, tolerance is moderate, and the roughness is high. Machining is used for making the simple to the complex shapes, small to the medium, and the tolerance is low, means we can control the dimensions very closely, and the roughness is also low, means very good surface finish can be realized. So, we have seen that the casting, welding, forming, and machining, these are the common material processing routes, and we have seen that the process capability of each process is different. So, the choice of particular processing method and material combination is not necessarily based on the one which will be offering you the best combination of the properties, but what is more important, that the process which offers the acceptable properties, but the process is most economical, because whatever will be made, that will be made for producing the things for the society. So, it is important that the material is processed to get the desired size and shape of the product with the acceptable set of the properties, but economically, so that the maximum profit can be realized by making the product at a low cost. And therefore, again I will say, choice of processing methods, whether it is casting, welding, machining, or forming, and material combination is not necessarily one that results in the best properties, but what is more important, the material and processing combination that offers the acceptable properties, but the highest returns and profits, so that the product can be made available to the customers and users at the lowest possible cost. Now, we will see the material processing versus manufacturing versus production. So, the material processing focuses on the initial steps of the transforming raw material into the useful state through the processes like refining, mixing, grinding. Often, material processing involves chemical or physical changes that to alter the material properties, and material processing may not create a finished product, but rather it offers the intermediate material ready for the processing. Okay. So, transforms the raw material into useful state, it offers the changes in material properties, and it offers the material in intermediate condition, which can further be processed for making the products. In manufacturing, on the other hand, involves a complete conversion of the raw material or processed material into the finished product using all resources like machinery, labor, assembly, etc. Typically, it includes multiple stages like cutting, shaping, joining, finishing, and then assembly, testing, etc. Primarily, manufacturing is primarily concerned with the creating tangible goods, okay, goods that are physical in nature and can be seen. Production encompasses the entire process of creating goods or service. It includes planning, organizing, and managing resources. Production may involve both physical manufacturing processes and non-physical services like design, marketing, and customer support. So, as far as the scope is concerned, for production it is wider than the manufacturing, and for manufacturing is wider than the material processing. Production can include the intangible products like information and knowledge along with the tangible products. So, as far as the scope is concerned, we have a sequence of materials processing, lowest in terms of the scope, then manufacturing, and then production, which offers the widest scope. So, this is just an example where the material processing versus manufacturing versus production. Material processing, a steel mill processing raw material iron ore into the steel billets. This is the part of material processing. In manufacturing, using the steel billets to fabricate car parts on an assembly line. Then production, entire process of designing a car, sourcing material, manufacturing the parts, assembly the car, marketing it, delivering it to the customer, entire thing falls under the production. Now, I will summarize this presentation. In this presentation, basically I have talked about the conventional material processing techniques like casting, welding, forming and machining and their process capabilities, modern trends in the material processing, and the comparison of material processing, manufacturing and production engineering. Thank you for your attention.